Now we will consider assembly of charges to find out the net force. So assembly of charges will be considered now. Okay, in this case consider a figure. Origin O, there is charge Q, another charge Q1, third charge Q2, consider one more, you can consider Q3. Okay, so you can consider in this way. This is the reference point and this is the final point. The distance between these two is R, and this is R1 and this is R2 and R3. Now if we wish to find the net force at this, then force due to this, that is R minus R1, you can say R minus R1 will be this position vector, R minus R2 will be this position vector, and R minus R3 will be this position vector. So net force will be, it follows the superposition principle, so on the basis of that it will be F1 plus, so the total force will be F1 F2 plus F3 that follow the superposition principle. Okay, so F1 can be written as, means force on this due to this one can be written as, take 1 by 4 pi epsilon common from all of these, so it can be Q1 divided by R minus R1 cube, and at the top it should be R minus R1. Okay, in this direction this magnitude plus F2 will be 1 by 4 pi epsilon due to this charge at this Q2 divided by R minus R2 is cube, R minus final position vector minus initial position vector R2, and the force at this due to this charge will be Q3 divided by R3 cube, final position vector minus initial position vector. Now in this way force due to assembly of charges is given here. This is F is force at Q due to assembly of charges. Now let us take one example. There are two charges Q1 and Q2. These are located at points this and this. Calculate the force on point charge at 1 nanocoulomb located at this point. If Q1 and Q2 is given here. So first of all, let us draw the position of the point charges. First charge is placed at Q1 is placed at 204. 204 means y-axis is absent. So if you are considering x, y, z, then your point will be somewhere x is equal to 2, z is equal to 4, somewhere here. Point is here. This is Q1. Now Q2 can be considered as minus 305. Again it is y-axis is absent. So x is minus 3 here, downward, minus 3, and z is 5, so it should be somewhere here, minus 3, 0, 5, that is Q2. This is Q1 and this is Q2. And third point, that is point of interest at which we have to find the force, located at x is equal to 1, y is equal to minus 3, and z is equal to 7. Somewhere you can say here. Okay, 1, minus 3, 7. Visualize this in 3D, then you can recognize the exact location. This is charge Q of value 1 nanocoulomb. This is of minus 2 nanocoulomb. This is of 5 nanocoulomb. This is our system of charges. Now we have to find the net force on this charge due to this system of charges. So consider it as origin. This is considered as R1. This is considered as R. This is considered as R2. So the force on this due to this will be this one. Force on this due to this will be this. So this will be net force on point charge 1 nanocoulomb due to these two charge systems. So F1 can be written as K Q1 Q divided by R1 Q. You can say R1 R. So you can say R1 R can be written as R minus, okay, let me correctly write R minus R1 cube, and at the top it should be R minus R1. Okay, now F2 will be force on this to do this will be K Q2Q divided by R minus R2 cube R minus R2, and in this way net force will be F1 plus F2. As we have seen, this follow the superposition principle. And this F1, now let me write the value. F1 will be K 5 into 10 to power minus 9. Q will be 1 into 10 to power minus 9 divided by R minus R. R minus R1. So it should be 1 minus the position vector of this is, the coordinates of this point is 2, 0, 4. So R minus R1 will be 1 minus 2 in the direction of AX plus minus 3 minus 0 minus 3 AY plus 7 minus 4 3 AZ. So it can be 1. So in the denominator it should be 1 square plus 9 plus 9 this power 3. Okay, this is F1, and F2 will be K, Q2 will be minus 2 into 10 to power minus 9 into Q will be 1 into 10 to power minus 9 Q2 final minus initial 4AX final minus initial KY final minus initial 2AZ divided by square root 16 plus 9 plus 4 power 3. Okay, so when we will solve and add these two forces, the final force can be, just I am writing the final answer, that will be minus 1 in the direction of X, minus 1.275 in the direction of Y, and 1.39 in the direction of Z nano-Newton. This is the net force acting on charge Q in this system from these two charges. So just I am taking the superposition theorem in which these two forces are added up, and that will give you this final result. Now after getting the force between the charges, now we will discuss the electric field. It means the region around any charge in which another charge can experience a force. So the region in which another charge can get forced is called electric field. Now in this study we will quantify this region where another charge gets forced and how much force will be experienced on it in its neighborhood. Now to understand the influence of this charge in the surrounding, we define electric field intensity. Thus, electric field intensity means how much force or influence of this in its surrounding. Now, from this we can write E is equal to force experienced on the test charge. For example, this is considered as test charge. Then the electric field intensity will be force experienced divided by the test charge. Consider it Qt. Okay. Now, as we want to know the influence of charge in its neighborhood, this must be independent of the Qt. Means what charge we are placing, it does not be dependent on the field. So, according to that, E should be F by the test charge, and from here we know that F already we have studied 4 by epsilon. For time being, consider the air medium, then it will be 4 pi epsilon naught Q1, that is this, and Q2 is our test charge. Again I have written Q2, so Qt is our test charge divided by the distance between the source charge and the test charge. For example, R square in the direction of R. This is R, and in the direction of radial vector R. So this is the force. We have studied this, so I am not again discussing it. Force divided by the test charge according to the explanation given here. So from here we find electric field intensity will be equal to the 1 by 4 pi epsilon naught, the Q1 that is available here, that is source charge, divided by R square, and still it is in the direction of R. So it is directed away from the charge in the direction of force. So we can say it is directed away from the charge. In this way, we can conclude that if Q is less than 0, means Q means the source charge, Q is less than 0, then the electric field will be directed towards the charge. However, if it is greater than 0, then electric field will be away from the charge. Away from the charge. When we draw the electric fields in terms of lines, for example, like this. In terms of, these are the lines near to which any charge will experience a force, and as we came to know here, E is proportional to the distance between here to the test charge square. It means as we move away from the source, field intensity will reduce because it is inversely proportional to the distance square. So as you go on increasing the distance, the field intensity will go on decreasing. So that we can understand here, if we make it more lines like that, and if you are here and coming towards near to the charge, source charge, the concentration of the lines becomes stronger. So it means field intensity will be high. So as you are coming closer to the test charge, the electric field intensity becomes stronger.